Thank you all guys for having invited me to this event once more year. And I would like to start with my presentation by demystifying Apple Pie and the Touch ID. Before anything to be said, unlike some media have published on the internet, I didn't publish any vulnerability on Touch ID on Apple Pay. My talk will do and will deal with a project I did some months ago. No information was about this project, so I want to come here and demystify what's Apple Pay and Touch ID. I want to really brushed upon Apple. I wanted to criticize Apple Pay and make them feel shameful. So Apple Pay research is work in progress. That's very true. As many other years, they told me that the characters in this presentation was too a small size character, so you can download it from Twitter and get it online. There is no zero-day vulnerabilities in this talk. This talk is about Apple Pay internals and Touch ID implementation. You won't find any open attack on the internet because you require to have a device jailbroken. My talk will be split up in 4 parts. Two parts are theoretical. They are very simple because you have to finish have lunch. So I will introduce you to Apple Pay, then I will demystify Apple Pay, and then let's move on to messing with the runtime and by using C tracks, and then on part 4 we'll command not on vulnerability but with the false sensation and feeling of security when developers talk about Touch ID and they do Apple Pay things. My name is Sebastian. I always like hitting the ball, and I like soccer and all this stuff. What's Apple Pay? Introduction to Apple Pay. You can see say mobile payment service and digital wallet app that uses NFC to initiate secure payment transactions between contactless payment terminals and Apple iOS devices. How can I use it? Very firstly, you need to buy the iPhone, mobile phone. Once you got the iPhone, you can do it with in Pay in store. You purchase by just tapping the phone against a contactless POS and placing the finger on the Touch ID. Always putting the finger on the fingerprint to update the payment. You can even do so with the tip of your nose, should you like it. Later, the other option is on Pay in mobile apps. I mean, on iPhone, you have the button inside the application, so you press the button, and this is it. You got charged. A little bit interesting. What is the secure element? So let's make it different between host car emulation and secure element. My fellow members talk about this before. Secure element is a tamper-resistant platform capable of securely hosting applications and their confidential and cryptographic data in accordance with the rules and security requirements. It can be considered a chip that offers a dynamic environment to store data securely. These devices cipher it and very firstly secure that third parties, entities, untrusted can access it, and no tampering is allowed. This was started down by Google Wallet. Now let's move on to another solution, and it's used by another important application whose name is the same as the one of the terrorist group now, which is ISIS Wallet, which is been renamed because the public relations person say ISIS Wallet, but they have renamed the same Apple Pay. And the second option is the host car emulation, which assumes that any data stored on a handset is vulnerable and therefore restricts the storage of sensitive data to hosts on a cloud database basis managed to a high security standard. Preventing unauthorized access depends on 4 pillars: limited use key, the tokens, which we'll see what's going on, but basically a token is like a credit card, a fake one, which substitutes the real one that used by the user. Thirdly, we have a sector of double authentication, which is in the case of Apple Pay with the device fingerprint. And fourthly, a monitoring of the network to check that everything is done correctly with transaction risk analysis. As said before, this is the very first part. I don't want to go into deeper analysis, so let's move on to the demystification of what Apple is. What's Apple Pay? What do we refer by the name Apple Pay? We got 5 components. First one is Passbook, the application. If you go on the menu, you can get the Passbook and you can add your credit card in 2 ways. Then we will see what the problems derived from this are. You can take a picture of the credit card, you convert the image to text, and then if you get it captured in the object code, you move the information to the secure element and you assure it. And the other way is it introduces digit by digit. Second option, secure element. On the next slide is a portion of a chip to 7 or to 8, depending on the version of mobile phone, iPhone. This stores sensitive information belonging to the credit card, the token according to Apple. Thirdly, we have the secure encrypted and touch ID, which allows us to perform the authorization of a payment. We are the person who is registered and is the owner of this phone device. And the secure enclave stores the fingerprints of the fingers. In conformity with Apple, all the information is encrypted. It's a stunning lady. And then we have the NFC controller enrouting all the communication on protocol NFC, which allows us from the iPhone, I'm moving the communication to TPU and finally moves it to the correct entity. This is done by NFC controller. Then we'll check the binaries. The perspective of this talk has been approached. I've gone through this subject matter. I didn't find documentation available. So instead of doing a theoretical talk, I want to make it as practical as possible. What are the findings I made and the main obstacles for you to get to the point to reverse things and moving forward?
Que son básicamente los que se encargan de mirar que el estado de la tarjeta de crédito sea correcto.
And in fifth place, the Apple Pay service, which check that everything is okay and you are tokenizing all things properly.
Muy bien, entonces
so far, so good. So let's explain the tenet to you. What is the story in the secure element? According to Apple, it's only a token. A token is a credit card number representative of the original credit card introduced by the user. We are not storing the original card or the expiry date. Is a token. Nobody knows under no circumstances. Nobody can extract information interesting for it. What is it the token use? Like I said, we can consider a token like a fake credit card number to make a payment. You pass the terminal through the TPU, send to the payment network who contacts the token service provider. This is not a token. This is not a credit card. It's a token. So I need to extract the real information from the real user who is proceeding to pay in order for me to make the payment. I'm going very quickly. How are the tokens provided? Very basically, the user takes and puts the credit card on Apple's Pay, and it inserts the number of the account, the expiry date of CVV, and the Apple Pay application contacts Apple Pay service, which send the information to the payment network, which is composed of several actors and players which Later, I will upload an article. I decided to leave it out here because I don't even myself remember the name of this article. The credit card reaches the bank and talks with the token service provider. I got this credit card. I need to analyze a token. The token service provider gets you the token, and let's make the ciphering of the communication, and then let's do the process inversely, the other way around. When the process is in reverse, Apple Pay says these token keyed information, which are metadata of what I mentioned before, are stored in the unsecure element. So I'm talking about the token. What's a token? What's a token, really speaking? A token has this structure. It's based upon 3 layers. The 3 main layers of the token are, as you see on screen. I'm very interested in showing you the payment token data with all the information regarding your credit card. What can we find in the payment token data? We find 4 fields. Firstly, the data, which is a ciphering dictionary containing the information in the next slide. Then we have a header adding additional information to decipher the header I mentioned before, the typical signature to check there is no changes in between, and it is worthy of our trust, all the track down, and then the encrypted payment data. As I said before, this dictionary, which is a cipher, what information does it contain? It is made up of the several fields. It discovers things. Of course, you have the application primary account number, the expiry date, who is the holder and the owner of this account, the amount of the transaction of this payment, and other relevant information, but I won't mention here. But keep this in mind. We know what is a token, what is stored in a secure element. Very roughly speaking, let's move on. I got my phone, as Ricardo said before. If I want to hack, if I want to steal information from a payment on NFC, what can I do? The very first occurrence to myself with IC's wallet, digital wallet, you take the postman, you intercept the information on the antenna, and knows the information being transferred. The protocol says that when you are going to make a transfer in the communication, sensitive information is exchanged related of this credit card, the track 1, track 2, holder. I'm going to capture all this. To my surprise, when I made the payment, I didn't see a thing. I only saw zeros. What the fact is going on here? He's using MFSA, but it's not working. So I said to myself, let's see what other perspective can I add to this issue. My next perspective was the one used by the. I'm going to introduce a proxy of my own certification, and let's get all the rubbish out of it. First problem, they are making certification spin, and the binary in charge of the communications has been compiled with a sandbox profile restricting communications from the outset to it. That is to say, if you are using zero exposures, you are fucked up. You cannot communicate with a binary file. What is the solution? So you can get the binary modified with a hexamile editor and modify the profile of the sandbox. I will tell you later on. You need to change one word only. I modify the binary and restore it, and I start capturing the information. Here, over here, you'll see the token I mentioned before is data, the header, the version, and signature. If you go to this project, the GitHub, you get through the swipe and you'll get all the data from the user. It's the very first delicious meal for you to recover this information. What happens in a payment? Like I said before, I won't mention because you all know. each transaction is authorized with a one-time unique number using your device account number, and instead of using the security code from the back of your car, Apple Pay creates a dynamic security code to securely validate each transaction from the press release. And this is it. This is it. So the device account number represents the token, the one-time unique number represents the dynamic cryptogram, and the dynamic secure code represents the dynamic CBB. Now let's move on to the secure enclave, where all this information is stored. What is a secure enclave? In the case of Apple, not with Google Wallet, was with this is wallet on the SIM card. Here with Apple is part of a A7 and A8 chips used for Touch ID. According to Apple, within the secure enclave, the fingerprint data is stored in an encrypted form, which can only be decrypted by a key available. Whenever you are going to make a payment, you need to put your fingerprint on the biometric sensor. Otherwise, you cannot perform the transfer. Apple says to us, all this information is stored over there. It's never stored on the device. It's a counter-terrorist against terrorists. It's never. It's always cipher. And after a lot of research, I noticed that in conformity with the definition, this people is a 4 mega flash memory with their own operating system, which nothing has to do with the Apple's operating system, with the secure enclave processor, the subUtil tool as well. How can you access this tool? Is what is contained in the Randix of H7 Randix.dmg, which is located on this path. You have to count the very first 27 bytes, so it's necessary to strip out the very first 0 per 1 byte, 27, to make the DMG readable. I'll send you a Wikipedia link for you to check it properly. It's not about telling, okay, this is a tool and launch it. No, you need to be on the safe side, because you can spend money on something which is not that useful.
Entonces, bueno, yo dije, vale.
So I said to myself, if this is a 4 mega flash memory, and according to other opinions, it turns out that whenever the mobile phone reinitializes, all the information on the secure enclave disappears, is deleted. 2 plus 2 are 4. If the information on the memory deletes, this means that the information sometimes goes up to the memory as well. So where all this information can be stored, it can be stored on the phone. So I analyzed the Diamond biometric kit, which is the process doing all the biometric process with Apple Pay, and I realized that the memory direction address, there is a branch. So inside the biometric kit, we find a memory address. Such method is the one used to upload all the information to secure enclave. All these cross-reference, all these calls take information from the terminal and send it to the secure enclave. And from the secure enclave, we also take information and store it on the terminal. So when Apple says, okay, nothing of the user information is on the device, that's false. Many of these pieces of information on your mobile phone on Apple, unfortunately. And you need to investigate much more on this. So after all this heavy talk, am I doing fine with the time? So messing with runtime. Okay, Touch ID. So how can we meddle with the runtime and take information from the memory? And as I said before, what is the Touch ID is a biometric sensor on iPhone 5s, 6, and which has the purpose to allow users to unlock their device, as well as make purchases in the various Apple stores and to authenticate Apple Pay online or in apps. You have your fingerprint registered on the device. How Touch ID process, how does it work? You approach your finger, this scan the topology of your fingerprint, creates a series of nodes and store the coordinate 1, X, and scan the whole figure, and is stored properly. So scans for scannable objects, scan objects, construct input map based on scan results, construct a lower resolution input pattern, then run match comparison of input map with possible match identities. So these are the results. You can access the application or make the payment. After this theory being explained, now many problems come. I register a fingerprint. I'm going to make a payment. What is going on underneath? What is in the lower layer? We don't know. There's no documentation. Nobody has done a research on this public. If you check the papers sent launched by Apple, you can find a lot of information. So we are in a big ocean of ignorance. We don't know where to start looking for. So I said to myself, okay, I first need, whenever I'm making an operation with the phone, what changes in the files, in the operating system are happening? What is going on with the fingerprint? What is cooking underneath? So there is a tool by J11, workaround, file monitoring made by J11. Due to reason I don't know, this guy J11 didn't compile for iPhone 8, so I took with Pancake programs at the speedlight time. So in 5 minutes I will fix you. Oh, your fucking binary file. So once Pancake savage my ass from this, I started noticing that if you have downloaded the slide, you'll see better. Whenever I register the fingerprint, the Springboard keeps storing images, and the biometric kit creates the template list temporary file with the topology of the nodes and the coordination of your fingerprint. Then I identify the two binary files I like the most, the biometric kit and the Springboard. And there was a problem. I identified the files generated and the ones that could be of vital importance to my research, but I couldn't copy them or access them. Why? Because basically the processes were using the gunlink method, which when you receive the path from the file, it deletes the link. So there's no human way of copying this file because there is no such a file. So we are coming to the first world, this thinking world. So I don't know what it's looking for, but I can copy the files with this thing. You cross it out with storage and processes the binary. You put things inside, and you'll get to override this function of gunlink, and you'll get on the right to have an array with all the files. When you can get to the end of the final path, copy it, and that's brilliant. That's really brilliant. So I copy all the files. I'm happy, but DYL share cache. How do binary work with all these files? New obstacle. So all binary working with this, if I need to do a dumping of the classes and methods to create them, I need first to have the binary. So problems on the go. So on the public libraries corresponding to a framework has been compiled on a cache file. So you need to get this file to parse the structure and copy binary by binary and framework by framework, as you can see on screen. So libraries have been compiled into a big cache file. All libraries from system library frameworks and system library private frameworks are now located in system library cache con.apple byld, and then with the J11 tool you execute the first line, extract the whole thing, and the second option, which reads you to all the binaries contained in the cache file. The problem with this is that you're gonna take on a lot of gigs of space. If you know what you're looking for, get it. This is it. I got the binaries, so I can put your seatbelt. I can do a dumping of the classes and methods. I can identify which one are interesting for me, which one I can hook. And now I got a problem. When I'm going to touch him with the second, my phone crashed and reinitialized because all system binaries are compiled with the seatbelt, which is a kernel extension that restricts a set of features from being used from some processes and how I interact with them. What is the solution? Workaround. You can use ID utility to extract the entitlements and modify the seatbelt field of a binary, which is an XLM. So you modify the entitlement, but this is basic for you to get the seatbelt, and you change it. You parse it. You swap this with a hexadecimal editor. You push the binary, and this is it. Nothing is wrong. So you got it right. Now it's clear what is the foundation that sustains this whole thing. You have extracted the patterns, mission, steps to initiate our research, and now let's move on to the toughest part. Apple says to us that the map, the fingerprint thing with nose and topology of your finger, don't make such an effort because this is not a store on your mobile phone, it's a store in the secure enclave. You're wasting your time. If you make a backup, it's not on an iCloud store. So I took this as a challenge, as a defiance. What is the real truth about this? So I'm going to reverse the binary. I'm going to make a string. What is cooking underneath? There was a file, this path, which was biolog. You don't need to be very clever. So, you say biomethod and then biolog. Okie dokie. So it sounds very interesting to me. So I started checking it, and I see you are looking for the book log enable key. And by default to false. My gosh, these people have put the binary, and you can enable the debugging option and see information, but I don't buy it because it's Apple. My goodness, these are very, very expensive 800 euros phones. So I'm gonna create this file. I'm gonna name it this way and put it on this path. What can happen to the mobile phone when you reinitiate your mobile phone and play metal with the fingerprints? Can you get an idea?
Decirme, hola, mira, has metido un dedo y otro dedo, bueno, una polla.
Oh my goodness, you put my finger in, you put your dick in it. My goodness, my gosh. You put your dick in it, your finger in it. These are the 4 fingers you put in it. This file, should you looking for it, all your fingerprints are inside. Oh, what's going on here? What's the hell going on? When I register that, we're processing an image. The image has been accepted. We have put this shine inside. The remastered image is this. The grayscale image is this. Oh, you have created 6 nodes, which is the number of times you have to put your finger on the center. And this sensor topology, this is coordinate 1 on the angle, the surface calculated. What the fuck? How did you put this hand, this finger, this choice on it? Shame on it. This was I don't know the way around this, but when I activate this, my goodness, this is the surprising box. So I'm gonna tell you now what the binaries and interesting methods you have to check and to play around. Basically speaking, you may know you tune and make a pool of the binary, you push flash down, you do a dumping of classes and methods, and you'll get all the objective fields, classes, you know how to interact with all of this, because it's a real heavy thing to explain. So if you go to these websites like binary searcher, you put the binary on the header, point H, and you'll get all the information. I'm going to tell you that the 3 most interesting sections are the ones ones in charge of the biometric operations with biometric kit framework, biometric kit, and preferences applications. Regarding NFC control, you have the NFC controller, the near field framework, and some libraries, which is open source free code used by Android. If you want to check some failures and tricks, you can check the code instead of reversing. You also have the secure enclave with the septuple binary tool I mentioned before. You check it on the iPhone wiki. It's like the Bible for those of you who like iPhone. And you check this binary. I've been messing around with this binary, and I can get information from the secure enclave when they say you couldn't. But it's a known path. I skip it. Now, I'm going to show you 4 silly examples because my talk is about to finish. So I will tell you the 4 classes where you have to inject with cycling to extract information from the template and from the fingerprints, and to decipher the whole thing to extract the fingerprint from the finger itself. My biometric kit identity, this takes a class containing information of all the fingerprints registered on the terminal. Something that Apple says, oh, we don't store this, but it's a lie. So you have an entry for every fingerprint associated to the system, and this is the number of the fingerprint assigned correctly when it was created, how many times I used my fingerprint to access an application or to make a payment, and the number of the fingerprint corresponding within the system.
Luego tenemos la clase de template list, que básicamente lo que nos devuelve es...
We also have the BL template list, which is the template associated information to each identity enrolled into the device. The template is the image or the topology in this very case with all the nodes corresponding to the representation of the fingerprint.
Y lo mismo. Por aquí tenéis el nombre del fichero, el timestamp.
You get the template list, the timestamp, and if you reverse it, and you'll see it, you'll find the protocol in place, the way this information is stored through the process. If you reverse it, you can get the fingerprint back from the device. Template info. Template info has several fields. Some are public fields, compiling additional information regarding the fingerprint, how many times the fingerprint was used, and you have this sloppy thing, which is the encrypted part of the fingerprint with this topology. Here you get the number of nodes composing the image, the cluster of nodes made upon the image, the area surface scanned. I did several tests, but perhaps my fine tests didn't allow me to do more. So if you have broader and grosser fingers, you can do it with a sensor. This is the BioClock-based class. Whenever you make an operation with Apple Pay or Touchery, all the logs information contains all the logs down for the Touch ID component. You can dump all the information. You don't need to decipher the files of topology because it's dumped over there. And then the XPC protocol to send information with the biometric XPC server. Here you got 2 interesting things. Directly you'll get the cache where the fingerprint is registered associated with an identity. We say that the fingerprint is the identity to be registered on the terminal, and instead the catacomb files is one I'm signaling. This is this file according to Apple. Apple says this file never is stored, and you can access this file whenever you want to. If you go to this cat, you'll find this file containing all the information of all the sloppy things registered by the sensor. The sensor registers everything, not only your finger. So it is a template that contains all information about the fingerprints added into the system. And the very interesting part is the fingerprint, which is encrypted. So some information is readable, but most interesting one is base 64 encoded and encrypted. This is the template layers .cat file, and this is the encrypted part of the fingerprint. You do a 64, open it with a hexadecimal editor, and this is the OM file generated by Apple to create the fingerprints. You have to refine the binary and see how things are working properly. So in the very it's like being a Pokemon coach and trainer. You have to spend so many hours and see which is the best one. I will show you the best and the most interesting ones. Gotta catch them all. We first have the decode catacomb data V1, which is this. This file I saw you before. You saw the encrypted method. So this method receives parameters and gives back. And if you want to decipher, you can go with this method, decode catacomb data V1. Second, pull the back image data, brings back not the final image from the secure enclave, but the one you get when you put the fingerprint in the device. It gets you the information on topology, enables the login of the secure enclave protocol, and then the two remaining ones correspond to the secure element. I overviewed, but I didn't meddle around with them a lot. You have the get data, read binary, get applications, get certificates, and all this stuff. And the names tells you this is the juicy thing in between. Do I have 6 minutes left?
¿Cuál es el problema con el touch? ¿Cuál es el problema con las implementaciones del Touch ID que hay a día de hoy?
Regarding the implementations of the local authentication, so you can use the several strategies with the local authentication. I will skip it very quickly. You don't have okay. LA security, local authentication trusts the OS. In keychain trusts the secure enclave. There is no direct access to secure enclave, no access to registered fingers, no access to fingerprint image. The verification comes from the hard disks and the operating system. If you want to bypass this and make a payment on Apple Pay and all these non-banking applications, with the second factor of authentication, you first check if the binary is using the local authentication framework. So you check the can evaluate policy, which pre-flies an authentication policy to see if it's possible for authentication to succeed. And thirdly, the evaluate policy evaluates a specified policy with a Boolean value, which is true or false, depending on if this fingerprint is correct or not. This is the example of the code. This is the evaluate policy, which checks if it can evaluate for the specific fingerprint. If successful, it gives the way to the application. If not, it gives you an error and go back to the password for the word of the application you defined before.
Iba a hacer la primera demo, pero mejor da igual. Básicamente con esto de aquí lo atacháis a un proceso y os saltáis el Touch ID.
You attach this to a process and you escape the application. You can make the payment without swiping your fingerprint. Should I conduct a demo for you, I guess?
La demo eran dos demos.
I got 2 demos. One is a live demo and the other one is a video.
Vale. Lo que hago es, voy a hacer la prueba con Dropbox, ¿vale?
I'm gonna use Dropbox. Put your finger to access the secrets of this application. I put a fingerprint which is not original. I access the application. So I can see that I can access the application. Great. I copy the sloppy thin up sidekin. I put it over here. And there you go. I'm hooking the method, regardless of I'm putting a good thing or a bad thing. It tells me something. I'm testing by I'm getting the access. I execute, and when I open the application, it says passcode out. You didn't put anything, and you skip it. Passcode skip, and you access. This applies to Apple Pay to make payments. First demo. Second demo.
Bueno, lo que os comentaba antes. ¿Quién la está cagando realmente con
Who
esto?
is screwing up here? What's out there? Besides Apple moving the technology and they are doing this fucking shitty way. So we got Fastpad, Amazon, Naughty. This is the bad sheep in this family. So you want to, instead of modifying the ordinary time of execution, you want to modify the binary. You want to tamper the binary. You knob the branches equal, knob, and you make the knob to be executed all the time. If you receive an iPhone on the string, you can access an application with gear brake or not, or is explodable or not. If you want to access the banking account system, it's enough to find the method for you to write in a knob to upload the binary, and that's it. Brilliant. Do I have time for conducting the second demo? Yes, of course. I'll conduct the second demo live for all of you guys. And you can do it with the tip of your nose. I'm a single, I'm a bachelor, so a girl can help me with her finger. I will build a hotspot, and you can decide on the go how things are working. Somebody, girl from the auditorium, somebody of you want to help me out with this situation? Don't flatter me. I know you for sure, man, at the back.
Voy a conectarlo al wifi, ¿vale? No me petéis el wifi, por favor, que si no me vais a joder la demo.
Please don't screw that my Wi-Fi, so you will ruin my demo.
Vale, Mythic, solteros exigentes.
Imitate demanding bachelors and single men.
Vale, ya me estaba acojonando porque no aparecía el AirPlay, digo, no me jodas.
Here we go. I was fucking scared of the whole situation. Somebody from you, any one of you, can put their finger in it. I don't know if it's going to work, guys, but I'm putting my nose on it. There, here we go. Here we go.
Es un poco para hacer la coña, o sea.
No, this is a fucking joking thing. Don't imitate those who use the tip of their noses to do this kind of things, please. Whatever part of your body or organs are usable for this purpose. It's not that joke. It's magic. This is magic. I love this guy, this magician on screen. Conclusions we can draw. My talk was a kind of funny, joking thing. There's not a real vector of attack that can trigger effects, because you need first to have the device with gear brake and the structure from Apple. Even though you scratch it, you'll get information from the memory, and you have detected the files. It's a robust, in spite of it, it's a robust Apple technology. So a jailbroken device is required to at least scratch the surface, and with even that information obtained is not highly sensitive. That's what it's happening. So if you are developers, you said that the Touch ID integration works better with keychain ACLS. The integration with local authentication framework is not recommended to protect your assets, like I said before. Thank you guys for your participation, the organizers, and thank you, especially all of you, my fellow attendants, for having listened to a very heavy presentation.
¿Tenéis alguna pregunta que pueda responder o algo?
Should you have any questions, please raise your hands. He will kindly ask you all. And will respond to all your questions, of course, as well.
Muy buenas, Sebas.
Oh, good afternoon, Sebas. Regarding the part of point CAD when you were trying to decipher with the code method, have you ever tested and tried if they have anti-replay mechanisms? I take my fingerprint from mine, I copy on yours. That works. You copy the template, you paste it on the other one, and it's working properly. The problem with this is that nowadays it's only supported by some American banks. In Spain, it is done in a very sloppy way. They want to use their own wallet solution here in Spain. So if you want to test how these things work, you need to go to the United States and test it over there. I did this test in the States when I was working there, and I never thought about creating a replay or anti-replay that you can copy the file and paste it on the other mobile phone. Any more questions? No more questions. Thank you, Sebas, for your wonderful presentation. Thank you.